open de zitting van de commissie ter beoordeling van het proefschrift en de stellingen van Bart-Jan van Straten, Master of Business Administration and Master in International Trade. De verdediging zal nu verder in het Engels worden gevoerd. I switch over to English now. I request the promovendus and the paronyms to go to the lectern. First of all, a very warm welcome to all of you in such large numbers today at the public defense by the candidate of the dissertation entitled From Surgical Waste to Medical Products. The Board of Doctorates of the TU Delft has installed a committee to evaluate the dissertation and propositions. The committee will now have a debate with the candidate in public. It's an honor for me to present to you the committee members, to whom I extend a hearty welcome. And these are. Opposite to me on the right-hand side, Dr. Arezzo from the University of Turin, Italy. Next to him, Professor Tuithoff from the University of Twente. Next is Professor Janssen from LUMC in Leiden. Next is Professor Bakker from TU Delft, and she is from the Faculty of Industrial Design Engineering. And then we go to this side, on the very left of me, for you to the very right, is Professor van der Elst from the Faculty of Mechanical, Maritime and Materials Engineering. Next is the co-promoter, Dr. Horeman from the same faculty. And to my other side, to the left for you, Professor Dankelman, also from that faculty and being the promoter. My name is Professor Smit. I am representing the rector for this session. I'd like to start now with the opposition, and to that I invite Dr. Arezzo to come with the first question.
Thank you, Meneer Director and waarde promovendus. My first question relates to, I would like you to discuss more in details the technical point of view of how do we optimize the cycle to recycle polypropylene and produce medical instruments with it.
Zeer geëerde opponent, dank u wel voor deze vraag. I will answer you in English. To optimize the stream of polypropylene medical waste, as where you refer to, in my opinion, needs to have a mechanical recycling approach instead of chemical recycling. We know with chemical recycling that we split up the polymer chains, and with the mechanical recycling, what we do, we preserve those molecular structure, we preserve those chains, and we immediately grind it and injection mold it. Those are all, of course, some steps, also manual steps, so we have some manual labor in that. And there's some optimization in there, but it also depends on how you define optimization. Is it in terms of energy? Is it in terms of human factor? Is it in terms of return on what you get back?
Basically, I would like to ask you how to reduce the maximum of pollution and how to increase the quality of the material that you produce.
Yes. If we want to increase the quality of the material, we have to look into the end result of the injection molded polypropylene. We did tests with dog bones for that. We made different mix ratios. We compared 100% polypropylene with increments of 25% to 100% recycled polypropylene, and we saw some remarkable findings in there. When we tore the dog bones apart, we calculated the ultimate tensile strength and the strain, and what we found out was that if we increase the mix ratio to 100%, the hardness increases, so the so-called short D value, but also the ultimate tensile strength, the UTS, increases a lot. And it increases from 13.5 megapascal to 36.5 megapascal, which is almost 14%. And also the hardness increases to 72 Shore D, which is fine for us because we think that in medical circumstances where we have a lot of moisture, disinfection on 90 degrees, 134 degrees steam sterilization, you might want to have harder material properties. So it could be a benefit. So in terms of reducing pollution, I think you refer also to the handling because we get medical waste in which is polluted with stickers, with other material, which after the surgery goes in one big bag and is pushed and then it's transported to the facility or the micro manufacturing facility where we recycle. There's a lot of pollution in there. You can only reduce that pollution either if we have a smart filter system, like we did with the face masks. We tried different filter systems to filter out the aluminium bars. We also looked at it with the stickers for the polypropylene. It's a little bit harder. The easiest would be to design those stickers and those accessories also from the same material so we can...
Okay. One further question is, you know that polypropylene that we recycle should be clean. At the beginning, at least. This is what the law allows us to do. But you know that we produce at least 6 times more polypropylene that is contaminated in the OR. This would raise immensely the excellent work that you have done so far. If you could please argument on which are the next steps from the technical point of view. Which are the dangers if we risk to create pollution by reprocessing this contaminated, and how safe this is for the operators and for the patients that receive this.
Yeah, I know what you mean. The pollution results also in less strain. And so if we have that stickers, we get more porosity inside. When we injection mold it, we see that the strain goes back even to 6%, which is low. So we want to have as few pollution as possible. And manually treating that waste needs to be clean. But if we look to the future, if we also want to have polluted or contaminated polypropylene blankets, which are also used with patients, we somehow have to think on stuffing them in a bag, which we, in a bag or a bin, can immediately melt it without touching it and get material out of that. I don't know if that somehow answers your question.
Yes. My final question, if I am allowed. You conclude chapter 4 saying that further research in recycling, refurbishing, and remanufacturing and reuse of surgical products with a focus on energy consumption during the melting process and CO2 footprint is needed to understand the true impact of this. Can you elaborate more? What is your next step in this, and how do you think that we should move further, also including the evident need of redesigning laws to be authorized to handle this material and to reuse it?
Yes, we are only at the beginning. Unfortunately, we cannot find a lot in literature because there is a lot of literature on recycling polymers and stainless steel, but not in a hospital environment, not with potential contaminated material. So that makes it a little bit harder to explore for us. And the whole process of optimizing that needs further research. We need to characterize all the waste mixes which we collect from the hospitals, and somehow, that's also what we think, put it in a database, to make an open source knowledge database, maybe as a kind of plug-in for engineers, for designers in AutoCAD, where we have all the material mixes after being recycled, with their material behavior in there, so that we know if we want to design something from recycled material, that we can use a combination of PET or polystyrene or polypropylene or polyethylene, which is used a lot, in the different kinds of mixing ratios. And that would be an important next step to make that visible.
So, in conclusion, you think that there are more materials that we should include in similar process, and which is the next step in your opinion?
Yes, we have our plan to orientate on more recycling streams for other types of plastics, polymers, yes.
Okay, main director, fine.
Thank you very much, Dr. Arezzo, and also for coming all the way from Italy. I'd like now to invite Professor Tuithoff to proceed with the opposition. You have the floor, Professor.
Thank you, meneer de rector. Waarde promovendus. I want to start by saying I admire the courage that you took to address this topic, and you can also see from your thesis that you performed science from your heart, and you need science to support this team because it's so important. And I think one more thing to say is that this thesis is just a piece of all the things you did together with Tim. You raised the organization Green Cycle, in which all of these studies have been performed and will continue. And it means also a gigantic efforts also on the logistics side to have performed some of these studies, which I want to address because it's not in the thesis, but everybody should be aware of that, I think. But obviously I also have some things to discuss with you, and I would like to ask meneer de rector to read out the propositions 1, 2 and 5.
Oh, well, that's quite a question. So, some work to do for the prelims. May I ask the waarde promovendus to read out proposition 1, 2 and 5.
Okay, number 1, mining materials from disposed products instead of mining materials from traditional geological mining models should be mandatory for medical device manufacturing.
Materialen gedolven uit gebruikte producten in plaats van uit traditionele geologische mijnbouwmodellen zou verplicht moeten zijn voor het produceren van medische hulpmiddelen.
Recycling a percentage of the ever-growing medical waste volume should be mandatory for the hospital sector, based on the resolution of Van S, Dutch Parliament 2021.
De ziekenhuissector moet verplicht worden een percentage afval te recyclen dat elk jaar sneller groeit, gebaseerd op motie van S, Tweede Kamer 2021.
To prevent waste, a law is needed that forces the industry to facilitate repair and reuse of all medical products, based on the EU resolution Right to Repair 2020.
Er moet een wet komen die de industrie dwingt om reparatie en hergebruik van alle medische producten te faciliteren, om verspilling te voorkomen, gebaseerd op de EU-resolutie Right to Repair uit 2020.
Thank you very much for your bilingual performance. And then I give now the floor to Professor Tuithoff.
Thank you. Well, being Dutch, those propositions stroke me quite in the heart because they all have a very high, demanding and mandatory character. And yeah, I've got a few questions on that. First of all, do you think your thesis will support these strict propositions? I don't think so. And then second, is this also the best way to achieve what we want to achieve?
Hooggeleerde opponent, dank u wel voor deze vragen. And thank you for your kind words about the thesis. And yeah, it is a thing which comes from the heart, that must be said. There's an important quote, and maybe you know it already, but I would like to quote it as introduction to the answer on your questions. And I quote that, "We did not inherit this world from our parents and grandparents. No, we are borrowing this world from our children." And that makes it even more interesting to do this research, which is exciting research, in effect. And I agree totally with you that some of these propositions might be contrary to the thesis. And indeed, it's right that there is an obligatory character behind these propositions. That's very much true. But I believe that's not the debate. The debate is whether can we make the world more sustainable by reducing the amount of waste, especially medical waste, as many papers reported that already. I can cite Minoglue 2017, who made a very nice table in their paper summing up all the kilograms of waste after surgery and per patient per day. And in Europe, it's easily 3.6 kilos. In Holland, we are 1.7 kilograms per patient per day, but in the US, we are on 8.4 kilograms per patient per day. And it's if you are on the OR, and we have some surgeons here, and of course we have been there quite some times, if you see how much waste is generated after one surgery, you think on yourself, okay, there is a literature gap a little bit on treating hospital waste. Yes, there is a circular economy model. The one I like a lot is the butterfly diagram. And there's also a personal justification, my personal mission, what I just said to you. So, yes, regarding Proposition 1, I totally agree with you. Should you oblige it, it's not the purpose. No, it's more the purpose of saying, on the one hand, there's so much growing waste in the world, medical waste, and on the other hand, there's so much pressure on raw material supplies, the scarcity. What we also see now with the geopolitical situations around us in the world, there's a shortage on nickel, which results in shortage on stainless steel. The prices go up, the lead times go up, and it will go even further. So from that sense, it's unfair if you are able as a manufacturer, as a medical device company, to apply those circular design engineering principles in your product. But if you don't do it, and you just wait until the raw material prices go up, and your price to the hospital goes up, it's an unfair economic model. So in that sense, you could argue to make it obligatory, yes, to use urban mining from the operating room and use those materials in your design for your new medical devices.
Okay, but we also see that there's in the green climate, we see abundant scientific evidence that we should do something about it, and you still see that it's very difficult to change people's minds. So I was actually, because it's so from the heart, thinking that you would rather go for a strategy where you want to do it bottom up and lead by example, for instance, but also explicitly, because I had the quote here, put more effort in training and education and make sure that it's more widely carried, I would say.
That's true. That's my personal favorite. Of course, we saw it also in our research teams with those wonderful people, and even with the students who help us, what the intrinsic motivation is. And the intrinsic motivation in hospitals is really, really high at the moment. All those people working in OR who see it daily how much waste is disposed. So that's not the problem, but the problem is more that we have a whole group of people, including politics around it, where we wonder how motivated everybody is. And maybe we need to put a little bit more push behind it. And that's why I was also so happy with the resolution from Parliament member Van Esch on 28 October 2021. It didn't help anything. I mean, it was voted away, but she at least submitted before our Minister of Health, Welfare and Sports to have hospitals recycle a fixed percentage of their medical waste based on our studies. So that was very honorable. And of course it did not come through because people don't want to have obligatory rules. It has to come from themselves. But we also have a climate law which says that in 2030 we have to reduce on CO2 49%. That's only, what, 7-8 years from now.
Yeah. Okay, thank you. To end off, I have a question from a completely different order. So now I'm being the engineer again. In quite some studies, so I don't pick out one study specifically, you had a low sample size, I would say. And my question is, why didn't you do a sensitivity analysis on top of that to see how sensitive basically the fact that you had a low sample size was on the discussion that you claimed.
It depends on which study, because we did do one sensitivity analysis on the LCA.
Yeah, but before,
that was on
for instance,
input
the
parameters.
material that you talked about,
that's
there you
true.
had a very low sample size.
Yeah. I agree with you. I totally agree. We also had to make some choices, and I also admit that no research is perfect. Certainly not mine and ours, but and also our research questions evolved and changed during the research. We were confronted with many things. With the face mask study, only with the threatening shortages on 17 March 2020, when we were forced to do, but we were asked by Franciscus Gasthuis to do a study for them to see if we could re-sterilize their face masks. Because they said next Saturday, it was a Tuesday, 17 March, next Saturday we don't have any face masks anymore, please help. Our microbiologist thinks that you can inactivate the virus if you sterilize it. So that's what we did. And it was a rat race, and indeed we should have taken more the time to do extra statistical analysis. I agree with you. Yeah.
Okay, thank you. I give the word back to meneer de Rector.
Thank you, Professor Tuithoff, for your opposition. I'd like now the opposition to be continued by Professor Janssen.
Meneer de Rector, dank u wel. Waarde promovendus, first of all, my compliments for your thesis, and especially the wonderful cover, and hopefully this is a sustainable picture in, 2050 or whatever, for the children we brought forwards to see how it is and how it stays. And you did a mining in literature as well on this subject, and my compliments for that as well, because it's a subject of my heart as well. Although I read it digitally, completely, you brought it in a non-sustainable way to me as well, so I'm able to have some comments and some questions as well from the paper I have here. First of all, I want to go with you to chapter 3, which is an interesting chapter, and I just pop in on page 49 and 48, and there's a figure with quite a lot of instruments which are, what they say, disposable. I have though some questions about that. Yeah, that's the cover. I work in the field of surgery with quite a lot of other instruments. I'm familiar with these, but these are, in my opinion, all reusable, but I find them here disposable. Can you explain a little bit more, and how much is this of the disposable part of the wastage?
Yes, I can. Hooggeleerde opponent, dank u wel voor deze vraag. And thank you for your kind words also. I will answer you in English. We collected 1,380 kilograms of stainless steel waste. Of that waste, which consisted of mesh baskets, which were not used anymore in Maastad Hospital, up to a lot of instruments which came from VUMC, Amsterdam University Medical Center, location VU.
There's the picture from?
Yeah, that's part part of their instruments.
Okay.
I cannot guarantee it's all of their instruments, but maybe that explains already something. No, but they had the whole alley with rooms full of old instruments which were not accepted anymore because of model changes, different models. And that's what we see more often, is that either a hospital shifts transfers from another supplier, and all the old instruments and implants are taken out and are just disposed of.
So to be honest, this is not representative.
Sorry?
This picture is not completely representative for the disposable part.
This is not for the disposable, this is reusable.
Okay.
But the 1,380 kilos consists of 50 kilograms of disposable, but they were collected in yellow bins, which is obligatory for specific hospital waste.
Okay. Yeah, just pop on and go on for some more questions to just more be precise. In your table 3 as well, you give 237, that is 70% is refurbished. Why is that amount so low actually? Because I work with these instruments and I find always, with disposable instruments for example, I can use them again, but unfortunately the law says it's disposable, so I have to throw it away.
Yeah, and there's a manufacturing tolerance, so what we also call the DIN norm. And take an osteotome. If you sharpen it, you can sharpen it until the tolerances of the original drawing are met. If you sharpen further, then it's not the original osteotome 12.5 centimeters anymore. Then it's osteotome 12 centimeters. And then we're not allowed to put it back into circulation because it's a different model.
But it's still that low, only 70%.
In this case it was, yes. Yeah, but we also had in this 1,380 kilograms, we also had a lot of mesh baskets, trays full, which were not usable anymore because of the holes in it.
Yeah. But do I consider this study actually as a pilot study, or?
It is a pilot study to see how the circular approaches could be applied, and we see a lot of other cases where the repairability is a lot higher.
How much?
Up to 85%, 90% sometimes.
That much.
Depending on the type. There are 22,000 different kinds of surgical instruments. And all the tweezers, the scissors, the osteotomes, the chisels, they are easily repairable. But if we have minimal invasive instruments in there, which have more fragile components, then it's already tougher to repair them. And sometimes, unfortunately, it's not, it's outside the boundary to supply it back.
And then I go to your conclusion of that part of that chapter at page 54. You say, finally, you did, of course, a cost-saving study as well, but you say here, the basis for a new approach in surgical instrument and waste management. Do you think this is the best option to reuse the waste, the urban mining, like what you propose?
It's always a hybrid, because, my favorite butterfly diagram between reusing, repairing, or applying maintenance, or refurbishing, or remanufacturing, which is completely different because we are building a new product out of an old product, or recycling. So it will always be a combination. And sometimes we did a study with the face masks where we reprocessed them in times of crisis. In the first corona wave from March 2020, suppliers asked €7 per mask to hospitals. And we calculated cost on €1.40 per face mask reprocessed, which is a lot cheaper. But now those face masks are a lot cheaper, so now it's not worthwhile to reprocess them. It's better to buy a new one and then collect it and recycle the face masks instead of reprocessing.
But that was in the pandemic. But now,
that's true.
In general, we have instruments and technology which we have in a disposable way. Should your conclusion not be more in the way of refusing, rethinking, reducing?
Yes, of course, yes. You are absolutely right. Yeah, I know what you mean now. Now, of course.
Okay. It took a while.
It took a while, yeah. No, it's also, I know you do that also in LUMC. It's the first thing you want to do is refuse. Yes. Don't you give the procurement department the message, try to switch from disposable to reusable. Yeah. That's the first win we have.
Yeah. Then I want to go to the polypropylene as well. You make new designs for the polypropylene and new purposes, etc. But shouldn't we stop actually to use the polypropylene? Is that not a better option?
That's not possible. Because if we stop using wrapping paper, then all hospitals in Holland have to invest a lot of money, because the alternative is a container.
Yes.
But the container means is that you have 2 disinfection cycles instead of one. One for the instruments, one for the container. You have to have a big inventory. Unfortunately, containers are made of aluminium, the most energy-intensive metal to make per kilogram. So it's how you see it. There's something to say for containers. There's something to say for polypropylene paper, but both, it's choosing the worst, the best of the worst.
At this moment, my hair is a little bit grayer. I grew up without polypropylene, and then we changed to polypropylene.
Yeah.
And why? You know why?
I was before my time.
Well, actually, I do not know either. It was it was the industry who said this is the best option. I'm only a doctor, and I'm working in the field, and I'm working in a patient-safe way, and they just told me that disposables, polypropylene, etc., was much better, doctor, than using or investing in other things. Yeah. So that brings me to my final question. Yeah. You're here now to become a scientist, actually, and my compliments for that. But you're also working in the industry, and as I was taught also in Delft, there's a triangle: the doctor, the engineer, and the industry. And here we're always saying the doctor needs material to be patient-safe. I agree. And then the industry comes to me and says, this is it. And I challenge the engineer actually to challenge the industry to remodel. Where is your position? And how do you fill your position in? That was my last question.
My position is born out of the personal justification. You, Professor Tuithoff, asked me a question which really came in. And I think if I look to the research we've done with our teams, we have met two kinds of people. Those who are really intrinsic motivated to create sustainability, and you have those who are short-term oriented on profits. And you're very much right. Unfortunately, we have a lot of greenwashing. Companies, people who pretend to be greener than they are. So that is, how must I say, regarding my position. I know that from a personal motivation, I'm convinced that what we do is the good thing. And we will never, never admit, and that's not possible in science, we have to be evidence-based. So if I tell to you this disposable pen is better than a reusable one, I have to give the arguments evidence-based and not make a brochure, it's less CO2. No, I have to show you in the 4 cycles that we really lower the CO2 during production, during the usage phase, or during transport or end of life. And I think that collaboration is very important. I even believe that we have to have more collaboration in a triangle, more with the hospitals, more with industry, more with universities, like you also see in the United States. That's
okay.
Yeah.
Work to be done.
Work to be done.
I will join you.
Okay.
Meneer de Rector, I'm satisfied with the answers.
Yeah, thank you very much, Professor Janssen, for your opposition. I invite now Professor Bakker to proceed with the opposition.
Thank you, meneer de Rector. Waarde promovendus, also my compliments for a great thesis. I very much enjoyed reading it, and I'm really happy to see so many examples of feasible reuse of medical devices in a world where the standard is still to dispose of stuff. So I'm from a faculty of product design, industrial design, so I'm going to ask my first question related to that. I read that in your discussion you argue that there is a need for anchoring circular engineering in our educational system. And at industrial design we're trying to do the same, as you may be aware, but not necessarily yet for medical products. So my question to you is, what circular design guidelines should I give to my students when they are going to design new medical devices?
Hooggeleerde opponent, dank u wel voor deze vraag. En very nice of you to say those nice words. Actually, I followed your MOOC courses, all of them. So I know you are quite an expert in this field. What we want to do is the basic principles, the circular design engineering principles. We also apply them on medical device engineering. So design, and you know all about this, the medical device from the principle that you don't give it a second life, but the third life and the fourth life and the fifth life. And use all the approaches, hybrid or not, from the circular butterfly diagram to again put in the value back, retaining the value from the value hill. The only thing is, what differs with normal products is that we are dealing with potentially contaminated products. We are working on a project at the moment for complex surgical instruments, which are used only once in the OR and then thrown away. This is quite costly, but we believe that if you can retrieve them and somehow disassemble them and recover those high-value components, you can reuse them in remanufacturing. So I would say when we apply the basic circular design engineering principles with the basic guidelines for contaminated products, then you have a whole package for the medical industry and the medical sector. And it's not that hard. We only need to want to do it.
Great, thanks.
But if I may, if I may add to that, we had a period where we had a lot of reusable medical devices, 30, 40, 50 years ago. And suddenly everything had to go to disposables. And we need to be aware that our Earth does not have enough natural resources to make all those growing number of disposable medical devices for hospitals.
So would you agree also with the the question actually that my predecessor, Professor Janssen, asked, do we need more leadership in design and engineering?
Yes, for sure. And I'm afraid we can only accomplish that leadership in the triangle, what you already said, the university, industry and the hospitals, and maybe the government also, to make it applicable, because we did some experimental research on remelting medical waste, but we were actually not allowed to do it because the legislation is in its way to go to a circular economy. And that was the problem. I had illegally to take a bag with medical waste on my back.
I have another question for you. And being from industrial design, we focus also a lot on the human. And for this, I would actually like to ask, meneer Director, can we read proposition number 7?
Yes, Professor Bakker, that's possible. Waarde promovendus, can you read out by one of the paragraphs proposition number 7, or both of them in 2 languages?
Socratic questioning is essential to educate hospital staff to distinguish sustainable products from greenwashing.
Socratische bevraging is essentieel om ziekenhuispersoneel op te leiden om duurzame producten te onderscheiden van greenwashing.
Thank you very much, Professor Bakker. Thanks. So I'm really happy you mentioned hospital staff in this proposition, because they are obviously a crucial part of this if we are going to transition to more circular medical devices. Now, you've worked for years, right, with medical professionals. Do you have any concrete ideas on how their ways of working can and should be changed to prevent so much medical waste from occurring? And also, relating back to the proposition, do you think Socratic questioning is enough?
Probably not, but what I like about Socratic questioning, and Overholzer in 2018 already reported that Socrates was a wisest amongst his peers because of his great awareness of ignorance. He knew that he did not know. And sometimes I'm a little bit surprised how easily people take the stories which are told to them. Of course, not only me, but we have a lot of discussions with people from the industry and from hospital staff, and then they say, yeah, but there was someone who said to me, it's far more better for the environment if we convert all reusable instruments to only disposables in the whole hospital. This is actually not so long ago. So because I'm sometimes so surprised, and I'm also a little bit fan of Socrates, because I think there are also a couple of Socrates here on TU Delft, a little bit against everything and yeah, being really critical. I think we have to be more critical, and the hospital staff is already willing. That's not the thing, but it's about knowledge. We should give them knowledge, and we should tell them how to judge whether a product is really sustainable, or how they could establish a green team and make an inventory where they can save on CO2 emissions, or on water usage, or energy usage in the OR, on the central sterilization.
I get that you have a different interpretation of Socratic questioning than I have, because you said giving knowledge, and I think that's just the thing that Socrates didn't do.
That's true. Yeah. But that was in the face of what my extra arguments. That's true. Socratic question is about asking the questions.
And how about protocols and habits and those things that are in the way of change?
Yeah. It's like, that's not easy. Protocols have been for quite some time, and patient safety is always on number one, but it's always used as number one argument for other arguments, if you know what I mean. So patient safety number one, costs are number two. And to change a whole procedure in a hospital is difficult, but we did it already. We did it with the Maastad Hospital. They are so, maybe, I don't know, mentality for Rotterdam, just do it. And that's good. And it needs to have a security from above, from the board of directors, from the healthcare managers. Everybody has to say the same. And as long as that happens, I think we will manage to do so.
Okay, thanks. I'm going to ask a more technical question now. So that's about the LCA on page 112, 13, chapter 6. So you have done a sensitivity analysis on a number of factors, but the one factor I think you did not do your sensitivity analysis with was the number of times of reuse of the mask. No. So my question is, how many times should you reuse at the minimum such a mask to still reap the benefits of environmental benefits? What is the minimum number of times of reuse for such a mask?
Yeah, we actually performed the LCA on 5 times reuse. That's indeed true. Yeah. And in the 5 times, you see indeed that we save 58% of CO2. This paper was published, and unfortunately, the reviewers didn't want us to publish the other results. We also calculated that with 5 times we saved 70% on land use, 35% on fine particle matter, which is quite high, I believe, and 57% on water consumption, which is a lot. To be honest, I don't know what the minimum is. I would assume that for every time of reuse there's already an environmental benefit, but I don't have the number by heart.
Looking at the graph, I would doubt that. But I'm very curious to see those results, actually.
Yeah, I'm happy to share those results with you.
And I also had a question, another one, and that you didn't do research into that, so it's a bit speculative. But are there situations when incinerating single-use devices with energy recovery, which currently doesn't happen,
energy capture,
is a better strategy from an LCA perspective?
Yeah, that could very much be true, but in medical device incineration, which is done in Dordrecht, it's a bit limited. So it's incinerated not so far from here, and there's no specific energy capture there from the incineration. So it's out of the scope, but it could have an impact. I agree with you on that, yes.
Yeah. So again, more knowledge needed there.
Yeah, there's more knowledge needed there, yeah.
Do I still have another question, or?
Well, time is more or less over, but if you have a very short one.
Then I'm very satisfied. Thank you.
Thank you for your understanding.